Okay friends, let us continue with the remaining questions in the static indeterminacy topic of structural analysis. A beam is said to be generally stable and statically determinate for general loading when the number of reaction component is how much? It should be 3. That is equilibrium equation. A plane frame shown in the figure below is and one hinge is given here. We need to say whether it is stable, determinate, unstable and all. So what I need to do, since it is the given figure is frame, I will apply a formula 3m plus r minus 3j minus rr. So the total number of members here is 1, 2, 3. Member is equal to 3. The total number of reaction in the 2 is hinged. Here it is 2, here it is 2, so it is 4. And the number of joints is 1 joint, 2 joint, 3 joint and 4 joints. There are total number of 4 joints. Then what is the value of RR? RR is equal to m minus 1. M is total number of members meeting the internal hinge, that is 2. 2 minus 1, which is equal to 1. So the value of ds, which if you substitute these things in the above equation, the value of ds comes to be, so please add one more thing here. See, here it is hinge is present, here also they had mentioned, I forgot this, here also one hinge is present and one more hinge is present here. So RR is equal to m minus 1 plus again m minus 1 for this hinge. As usual, since the member meeting here is 1 minus 1 is 0, it comes to be 1 only, and the value of ds, if you calculate from here, it comes to be 0. If the value of ds is equal to 0, then it is stable and statistically determinate. Next question. Moving on to the next question. Which one of the following makes statistically determinate beams? Simply supported, cantilever and overhung beams is determinate beams. Cantilevers and fixed beams. Fixed beams is indeterminate. Continuous beams and beams carrying uniformity and fixed beams, all these things are indeterminate. Only simply supported beam, cantilever beam and overhanging beams are determinate structure. Independent displacement components of each joints of a rigid jointed plane frame are, it produces 2 linear moments and 1 rotation. In case of rigid jointed plane frame, it produces 2 linear moments and 1 rotation. That is, the number of independent equations to be satisfied for the static equilibrium in case of space frame is, of course, in case of space frame it is 6, in case of plane frame it is 3. Make a note of these 2 points. Degree of static redundancy of a structure given in the figure. The given figure is frames, so ds is equal to 3m plus r minus 3j. Hinge is not given, so make use of this equation. I had already explained them in the many of the problem. Degree of static redundancy of a beam is the number of addition equation required in the analysis is very important. Shear hinge at a beam section releases shear force but transmits bending moment and axial force. Very important question, please remember this. The analysis of structure is calculating the magnitude and nature of various straining actions at salient points of the structure. The degree of static indeterminacy of a rigid jointed plane frame is equal to 6m plus r minus 6j. Since it is given as space frame, you need to go here. If it was given as a plane frame, you would have gone in this case. Next, what is the degree of static indeterminacy of a structure which is shown in the figure? Here dse is equal to r minus 3, which is equal to 6 minus 3, which is equal to 3, and dsi is equal to 3 times the closed loop. There is no closed loop since it comes to be 0, so 3 plus 0 is equal to 0 and total ds will be 3. So answer is 3. The perfect frame should satisfy the relation m is equal to 2j minus 3. Already discussed question. Relationship between the number of members and a joint in a plane truss will be equal to m minus 3, which is equal to 2j minus 3. Very simple question. The statistically indeterminacy of a continuous beam shown in the figure. See, since the beam is given, you had to calculate ds, which is equal to redundants removed minus redundants added. So total number of redundants removed is here 1. Since it is roller support, reaction is 1. Since it is roller support, reaction is 1. You need to remove 2. Redundants added. In order to make this as a thing, these two things are removed, that is 2. We need to add the redundants to be added. Since already the reaction which is present here is equal to total number of reaction is 3, no need of adding any addition. So the answer is ds is equal to 2. The number of unknown reactions to be found at a fixed support of the beam during the analysis is very simple question, which is equal to 3. And the last question of this unit, the degree of static indeterminacy of the rigid. If your ds is equal to 3m plus r minus 3j, you will get the answer as, okay, please. Last question, just comment for last question in the comment box what is the answer. If it is right, I will reply to your answers. Thank you, and all remaining question we will see in the next.